Hello everyone, welcome to another video of mine, and in this video I will be solving question number 4 of May June 2019, and the paper code is 32 and this is paper 3. The question is related to the differentiation topic, and here it is. Find the exact coordinates of the point on the curve y is equal to x over 1 plus ln x, at which the gradient of the tangent is equal to 1 over 4. So we know the gradient and we have to find the point where is that gradient. So we have to find the points, the coordinates. So this is just for simplification purposes. Let's suppose a graph is something like this. Let's suppose. So this is a point where the gradient of the tangent is, sorry, this is not the best tangent, but I hope you get the idea. The gradient of the tangent is 1 over 4. And we have to find the points where the gradient of the tangent is. We don't know y and we don't know x, and we have to find that. And we're going to find this with the help of differentiation. So yeah, let's do that. I'm removing this over here. So yes, so differentiating with respect to x is our first step. Differentiating with respect to x. We know what is this. This is simply the quotient rule u over v, where we differentiate it like this. Sorry, right, like d. So we are going to write the uh, denominator as it is v, and we are going to differentiate the numerator minus. Then we are going to then we are going to write the numerator as it is, and we are going to differentiate the denominator, and then we're going to do denominator square. This is how we differentiate when it is in quotient, like when it is in the division sign, you can say that square. So we're going to write dy over dx is equal to, so you can pause the video and do it on your own as well. 1 plus so this is v and this is u. Okay, so we wrote v as it is, and then we have the differentiation of x, which is going to be 1 minus x. You know that the differentiation of a constant is 0, and the differentiation of ln x is 1 over x. So just let me write it over here. D ln x is equal to 1 over x. So simply plus 1 over x, and this is then the in the denominator we're going to have 1 plus ln x square. So let's write it again as dy over dx is equal to 1 is going to get multiplied by 1, and ln x is going to get multiplied by ln x. We're going to be left with 1 plus ln x. X is going to get multiplied by 0. We are going to get 0, so no need to write that. And over here x is going to get multiplied by 1 over x, and what we're going to get, we're going to get 1, because x and x are going to get cancelled. So minus 1 over 1 plus ln x square. So you also see another thing over here, that the 1 and 1 are going to get cancelled, because 1 and minus 1 is equal to 0. So we are left with dy over dx is equal to ln x over 1 plus ln x square. And in the question it is given that the gradient of the tangent is 1 over 4, and we know that the first differentiation gives us the gradient. So dy over dx is the gradient of the tangent, and we know that the gradient is 1 over 4, so we're going to simply replace dy over dx by 1 over 4. So this is going to become 1 over 4 is equal to ln x over 1 plus ln x square. So simply cross multiply both sides. So 1 plus ln x square is equal to 4 ln x. So simply expand this with the a plus b whole square. We know that a plus b whole square is equal to a square plus b square plus 2ab. So this is a, this is b1 plus ln x square plus 2 ln x. is equal to 4 ln x. So what we're going to do is 1 plus ln x square, and just let me write this like this, plus minus 4 ln x is equal to 0. So we know that 2 ln x minus 4 ln x is going to give us negative 2 ln x. So we have 1 plus ln x square minus 2 ln x is equal to 0. So if you didn't understand this step, so let me do it again just for some. So it is over here. Now I'm explaining this. How did we get minus 2 ln x over here? So here it is, 2 ln x minus 4 ln x minus 4 ln x. So if I take ln x common over here, I'm going to be left with 2 minus 4. And we know that 2 minus 4 is going to give me minus 2, and this is minus 2 ln x. So that is how I got the minus 2 ln x over here. I hope you understood that. So simply let me rewrite it again. Ln x square minus 2 ln x plus 1 is equal to 0. So we are going to be, so you can see that, oh my bad, I'm so sorry, there's a bracket over here. Okay, so this is a bracket over here, it's above the bracket, ln x whole square. So as you can see that this is a quadratic equation right now, so we can either use the quadratic formula or the midterm break. So the midterm break is a much easier method, and it can also be used over here. So we are going to be using the midterm break. So in midterm break, when we are going to break this, so when we are going to add them, we should get minus 2 ln x, and when we should multiply them, we should get plus 1. So using midterm break, so this is ln x whole square. So simply minus ln x minus ln x, that's going to give us minus 2 ln x, and when we're going to multiply them, we're going to get positive 1 is equal to 0. Sorry, yes, you got the idea. So ln x minus 1, and then again minus 1, ln x minus 1 is equal to 0. So this is going to become ln x minus 1 whole square is equal to 0. We are going to take the square root at both sides. We're going to get ln x is minus 1 is equal to 0, and ln x is equal to 1. So we know that ln x is equal to 1. So we're going to take base on both sides. Taking base on both sides, I've explained this a number of times. E ln x is equal to E, and E ln x, E ln a we know is equal to a, so E ln x is equal to x, so x is equal to E. So what actually has happened over here, we know that when these two are equal, we know that if for example I have 2x is equal to 25 over here, as the bases are same, so the powers are same. So over here we already know that ln x is equal to 1, and we need to find the x. So we have just taken base. E ln x is equal to e power 1. So if the bases are same, then the powers are going to be the same, and we know that E ln a is equal to a. So simply like that we got x. But in the question there's another catch. In the question it's given that you need to find the exact coordinates of, you have to find the exact coordinates. So what we're going to do is, so we're just simply going to get y is equal to e 1 plus ln e. We know that ln e is equal to 1, so we're going to get e power 2. So your coordinates are e and e power 2. This is the point where the gradient of the tangent is equal to 1 over 4. And you can literally even check it. So pick up your calculator, and where we have find the first where we have find the first derivative ln x over 1 plus ln x square, you can literally substitute the value of e to check whether you get 1 over 4 or not. 1 plus ln e whole square, and you get 1 over 4. So you got the right value of x. If you got the right value of x, henceforth you got the right value of y. So with this, we are done with the question number 4 of May June 2019, paper 32, and I hope you understood it. Okay, thank you so much. See you in my next video. Like, share, and subscribe.